So since the last two lectures we are studying superposition theorem and Thevenin's theorem, which is a part of DC network theorem. So the third part in the series is Norton's theorem. So how to solve this? Again, if we have any arbitrary network consisting of only passive components, and we have seen the term load resistor, and we have to find current through this load resistor using Norton's theorem. So how to solve this? So how we do is, again we first find VTH using the same procedure as Thevenin's theorem. So this is same procedure as Thevenin's theorem. Then we find RTH, which is equal to RN. So since it is Norton's theorem, it is called as Norton's resistance. So again same theorem, so same formula, Rn equal to VTH upon IN. Okay, and then we draw the Thevenin's equivalent circuit. So it is two resistors it is a voltage source, current source in parallel with two resistors. So this will be Rn and this will be RL, and this is the current I, and we have to find current through this load resistor. So this is IL. So again we find the current. If you know the total current, we can use CDR. What is CDR? Current division rule. So IL equal to total current I into, we know this current also, Rn ke through current we know it is what? IN. So IL equal to I into IN upon RL plus RL, right? So this formula you have to use if you have dependent sources. So how to solve for independent sources, that we'll directly see using an example. So the question is, find current through the 10 ohms resistor. So as you see, they all are independent sources. So first locate the 10 ohms resistor. So this is our load resistor. So RL equal to 10 ohms. So what we do? So we have to find current through this. So first we find VTH. So we redraw the network, and what do? We remove the load itself. So let's redraw it. So here it is. What we find is VTH. So this is VTH plus minus. This is 15 ohms, 4 ampere, 5 ohms is nothing, 1 ohms, 2 volts, right? So how many loops we have? We have two meshes. So this is open, so we have one mesh only. So this current is I1, this current is I2. So again, if you see clearly, it forms a super mesh. So what is it? I2 minus I1 equal to 4. This is the first equation. So applying KVL to super mesh. So 2 minus I1 minus 5 I1 minus 15 I2 equal to 0. So minus 6 I1 minus 15 I2 equal to minus 2. So all will be plus if I multiply by minus 1. So this is equation number 2. So we have two equations, two unknowns. We can find I1 and I2. So minus 1, 1, 4. Minus I1 plus I2. So minus 1, 1. Then 6, 15, 2. So I1 is, I'll directly write the positive sign, 2.76 amperes anti-clockwise. I2 is 1.238 amperes clockwise. So these are the values, right? So we have to find what? VTH, right? So what path we can take? We can take either this path or this path. We cannot take this path because we don't know resistance of this current source. So let's take this path. I'll use a green pen. Okay. So plus VTH. So you have to writing KVL equation for VTH. VTH minus I1 minus 2 equal to 0. So therefore VTH minus, now the question is we have to take positive sign or negative sign. So if you are, which direction we have assumed? We are going like this, plus we are going like this, we have taken plus to minus. This is what we have taken, right? So we are taking current is already flowing anti-clockwise. So for anti-clockwise it is positive. So 2.76 minus 2 equal to 0. So therefore VTH equal to 4.76 volts. Next, what we have to find? We have to find Rn. So again, remove the load, substitute a Rn here. So for Rn, we already know the formula Vth upon In. So what we do? We short it. Right? So no need to draw that Rn diagram. Directly draw In diagram. So I write In. So this was for Vth. So again, redraw it. So now it is shorted instead of open as in the previous case. So this is 15 ohms. This is 4 amperes. This is 5 ohms. And what is this? This is iron. This is 1 ohms. This is 2 volts. Right? So we have to find this iron. Right? So what will it be? Let's see. So what we can do? We can take 3 currents. So I1, I2, I3. So you see that even if you are using Thevenin's theorem, Norton's theorem, whichever theorem, mesh analysis is very important. So make sure you are very much conversed with mesh analysis. Right? So again, this forms a super mesh. So I3 minus I2 equal to 4, equation number 1. Then apply KVL to this equation. So this super mesh, this is the super mesh, right? So minus 5 I2 minus 15 I3 equal to 0, equation number 2. This is the first mesh. So 2 minus I1, that's it, equal to 0. So here we directly get I1 equal to 2 amperes. So this is equation 3, right? Then solve equation 1 and 2. We'll get I2 equal to I3 equal to. You have to write the steps. I am not writing the steps. So minus I2 plus I3, 4. Minus 5 minus 15, 0. So I2 is, I'll take plus 3 amperes in anti-clockwise direction. I3 is 1 ampere in clockwise direction. Right? What we have to find? We have to find iron. So what is iron now? So iron is in same direction of I1. So I1 minus I2 is iron. So iron equal to I1 minus I2. Therefore iron equal to. So again there is a question, we have to take I2 as plus 3 or minus 3. So we have written this considering anti-clockwise sign. So we have to take, clockwise sign. So we have to take using clockwise sign. So for clockwise it will be minus 3. So I1 is 2 minus of minus 3. So therefore IN equal to 5 amperes going downwards. Fine. So what is Rn? Vth upon In. So therefore Rn equal to, what is Vth? 4.76 and In is 5. So 4.76 divided by 5. So 0.952. So 0.952 ohms. So this is Rn. So we have found out Rn, we have found out Vth and In also. So this is the current source. This is what? Rn equal to 0.952 ohms. And we have RL equal to, what is RL? 10 ohms. Right? RL, so this current is IN. So what is IN? This is IN. So IN equal to how much? 5 amperes. Right? So what will be by CDR? So I'll write here by current division rule. IL equal to IN into Rn upon Rn plus RL. So equal to, what is IN? 5. So 5 into Rn. Rn is 0.952 upon Rn 0.952 plus RL which is 10. So 0.435 amperes. 0.435 amperes. IL going downwards. So this is the final answer. Right? So current through 10 ohms. So let's continue further. Find Norton's equivalent across A and B. So this is the network. So if you see, there are dependent sources now, right? So I have two dependent sources. So two dependent variables, I1 and I2. So somewhere I should find I1 and I2. So this is I1, sorry, this is I2, this is I1. I have to find network across A and B. Okay, right? So first we write equations for dependent variables. So for that we'll require a clockwise current. So let's say this is I. So from the network, what we see, I equal to I2, both are in same direction, and I is flowing downwards, but this is flowing upwards. So I equal to also minus I1. So this is equation 1, this is equation 2. Next, just apply KVL to this closed loop. You can apply KVL. Here this is open, so you cannot apply, so no current will flow. So that's why we have not taken second loop current or mesh current. So 5 minus 10I minus 5I minus 10I2 equal to 0. Right? So I1, I2, we know I1, I2 in terms of I. So we can find I. So therefore 5 minus 10, I1 equal to what? Minus I. So plus 10I minus 5I minus 10, I2 is I equal to 0. So find I from this. So 10 minus 5 is plus 5. 5 minus 10 is minus 5. So here it will come 5I. So I is 1 amperes. So it is positive. So it is in clockwise direction. Right? Next, what we have to find? VTH. So across this only we have to find VTH. You have to draw a new network. I am using the same thing. Right? So we'll write KVL equation for VTH. Right? So let's take this path. If you want, you can take this path also. Okay. So 5 minus 10 I plus 3 I1 minus 10 into current through this mesh is 0. So minus 10 into 0 equal to minus VTH equal to 0. So what is I1? We know I. So I1 in terms of I is minus I. So therefore 5 minus 10 I minus 3I equal to VTH. So therefore VTH equal to, so 5 minus 10 into 1 minus 3 into 1. So VTH is minus 8 volts. Am I correct? Is it minus? Yes. Right? So next what we have to find? VTH. So we redraw the network. Sorry, we find RTH, right? Or RN. For that it is what? VTH upon IN. So we short the terminals. So this is A, B, this is IN. So this is 10 ohms, this is 3 I1, this is 5 ohms, this is 10 I2, this is 10 ohms, 5 volts. This is I1, this is I2. Am I correct? Yes. So again take clockwise currents, I1, I2, write the equations for dependent variables. So we cannot take I1 and I2 because I1, I2 is already given here. So let's say they are I1 prime, I2 prime. So what is I1 prime? Equal to I2. What is plus I1? It will be I2 prime minus I1 prime. So I1 is I2 prime minus I1 prime. Right? Yes. So this is equation 1, equation 2. So next we apply KVL to first mesh. So 5 minus 10 I1 prime minus 5 times, what will this be? I1 prime minus I2 prime minus 10 I2 equal to 0. So therefore therefore 5 minus 10 times. So I1 prime I want. So I'll keep it like this. Minus 5 times I1 prime minus I2 prime also I keep it like that. So minus 5 I1 prime plus 5 I2 prime. This is what minus 10 I2. So it is different variable. So I'll write I2 in terms of I1 prime. So minus 10 I1 prime equal to 0. So after solving this I get minus 25 I1 prime plus 5 I2 prime equal to minus 5. So this is equation number 3, right? So next apply KVL to this mesh. So 10 I2 minus 5 I times I2 prime minus I1 prime plus 3 I1 minus 10 I2 prime equal to 0. So I1 is extra. So what is I1? I2 prime minus I1 prime. So therefore 10 I2, this will be minus 5 I2 prime plus 5 I1 prime plus 3 times I2 prime minus I1 prime. So 3 I2 prime minus 3 I1 prime minus 10 I2 prime equal to 0. So therefore solve this, collect terms in I1. So this is I1, this is also I2. I2 is what? I1 prime. So we can substitute this also, I1 prime. I1 prime, I1 prime, I1 prime. So 10 plus 5, 15 minus 3, 12. So 12 I1 prime minus 5 plus 3 minus 2 minus 10 is minus 12. So minus 12 I2 prime equal to 0. So 4. Then solve 3 and 4. We will get I1 prime, I2 prime. And I2 prime is nothing but IN, which we require. So this we don't require, so I will not write it. If you want, in the exam you have to write it. So minus 25, 5 minus 5, 12 minus 12, 0. 1 by 4, 1 by 4. So 0.25 amperes going downwards. Right? So what is Rn? VTH upon IN. So therefore Rn equal to, VTH was minus 8. So minus 8. So as I told, the resistance can be negative. We are getting negative here. So minus 8 divided by 0.25. So 32. So minus 32 ohms is the Norton's resistance. Next what we do, we draw Norton's equivalent network. So here you have to write drawing the Norton's equivalent network. So IN we have found as 0.25 amperes. 0.25 amperes. Rn is minus 32. Rn is minus 32. RL okay, RL is not given, so we will not draw this way. We have to find the Thevenin Norton's equivalent network. So this will be A, B. So this will be IN equal to, this will be Rn equal to minus 32 ohms. Right? So this is the way we have to solve. Okay. So next sum is homework. So you can try it yourself. Find current through 2 ohms. I'll just tell what can be done. So again you observe there are dependent sources. So dependent variable is what? Ix. So you will find Ix somewhere in the network. So it is here. In the exam, if it is not there, means they have not given it. So you have to assume it somewhere or wait for the examiner to give you the change from university. Okay. So how will you solve? And remember, this is minus 10 volts with plus above and minus above. So there is a catch here. So current through 2 ohms. So this is the current through 2 ohms. So first step, what we'll do? We'll redraw the network. So I'll redraw it for you. So plus minus. This is for VTH. So it will be like this. And this is also minus 2x. So minus 2x, 10 ohms, 4 ohms, 2 ampere. Here you are finding VTH. So you can take left as plus, this as minus. and this is minus 10 volts. Or while redrawing, what you can do to make this plus 10, you interchange this minus and plus, and you interchange this direction also. So this will become 2ix, so it will be simpler. So what we'll do, this is again open, so this will be I1, this will be I2. So I1 will directly get as 2 amperes. Then just apply KVL here, you will get for I2. Before that, you will require Ix. So what will be Ix? Ix is here, right? So what is Ix? This is open, so Ix is 0. So this term will be 0. So I2 itself is 0. So I1 is 2 amperes, that's it. So then just apply KVL here. So you can take this part. So VTH, I think it will come as 10 volts only. No, 10 minus 4 into 2. 10 minus 8, I think it will be 2 volts. You just check it, I am not sure. Then what you will do, you will find RTH or RN. So RN is what? VTH upon IN. So for IN, what you will do? Instead of this, you will short it. And here you will find IN. So instead of 2 meshes, you will have 3 meshes. So 3 mesh currents, 3 equations. So you will find IN. It will be this current only. Current flowing through this loop. For example, I3, because this is I1 and I2. Then you draw the Thevenin's equivalent circuit and use the current division rule, which we have seen in the previous example. Okay. So this is the way you have to solve. Thank you.